Let's jump in with our first speaker, Nir Lahav from Bar Ilan University in Israel, who is going to be talking to us about the relativistic theory of consciousness. Can physics solve the hard problem?
So as he said, my name is Nir Lahav. I finished my PhD in physics in Bar Ilan University in Israel. And today I would like to show you a theory that I developed that try to suggest some kind of a solution for the hard problem of consciousness. And I call it the relativistic theory of consciousness. So as we all know here in this conference, consciousness is one of the biggest mysteries in the universe. How this 1.5 kilo of bloody, messy, gooey flesh create our conscious mind? But first of all, we need to clarify what are we talking about. So I will use consciousness in the canonical definition, let's say, from the 70s of Thomas Nagel, that consciousness is the answer for the question of what is it like? What is it like to see a red? What is it like to be near? For example, this cupboard that you see here most likely has nothing that is like for him to be, just exactly like people under anesthesia. So this will be our definition, and then the hard problem is how to switch from first-person point of view of someone that experienced an apple to the third-person point of view, the scientists that will look at the brain and will see only neural patterns and neural representations of the apple, but not the apple itself. So we need to know how to transform from those neural representations into the actual experience of the apple. And it seems that we cannot find in the brain the experience everywhere, just more and more neural patterns. So how can we do this transformation? There is a gap here between the third-person point of view and the first-person point of view. This is the explanatory gap and the hard problem of consciousness, you can say. What is this function, fx? How can we go from one to the other? And a bit more definitions here. So qualia are those quantities of the conscious experience, and phenomenal consciousness is when we take all of those qualia together. And it seems, as you saw, that they are private. We cannot find them except of the one that actually, except of the subject that observe them. So then, if it's true, if they are private, we encounter the zombie argument. We can think of this creature that is physically identical to me, for example, but with no phenomenal consciousness. And this is because if phenomenal consciousness is so private, it can be independent, or it's independent from the physical world. So we can think of such a weird creature like my twin zombie. So it has no phenomenal consciousness, but the zombie is very interesting, actually. It's not a dull creature. It has a cognitive system exactly as me. So it has representations. So when he will eat an apple, for example, my zombie will say, oh yeah, I eat a red apple and it's so tasty. I don't know what to say about this redness, so I guess I have qualia and I have phenomenal consciousness. So the zombie will think he has phenomenal consciousness, but of course, my zombie is delusional. There's nothing behind the representations. It's a bit like, if you want, you can think about Alexa, and a bit more sophisticated Alexa that will say, oh, I love this song. And you know, there is nothing there. It's just a phrase that Alexa knows how to articulate, but there's nothing behind that. So think about now, so the zombie is the most sophisticated cognitive system that we can think about. So this is more or less the argument. Oh yeah, we call those I see red apple or I love this song. We call those phenomenal judgments. So they have these judgments, but with nothing behind them. Now, if we take all the theories of consciousness, we can put them nicely, I think, in a spectrum. So in one side of this spectrum, we'll have illusionism. Everything, let's say the conscious experience is just an illusion. On the other side, we have another extreme, the naturalistic dualism of Chalmers, that say that if consciousness is private, then let's just add this as another element to reality. And all of those theories are a bit extreme and have some paradoxical consequences like zombies, but they do have something in common. Both of them assume that consciousness is absolute. And then it doesn't rely on the observer, and that's why the observer can be delusional, for example, like the zombie, if you like. But then we can do another thing. Let's assume that consciousness is relativistic, and then it's observer dependent. What will happen then? So this is the theory that now I would like to show you. And I hope that I can convince you that it can actually help us solve the hard problem and to understand what is this fx. In order to do that, let's speak about two examples from physics about relativity, and then through them we understand what does it mean to have consciousness as a relativistic phenomena. So let's start with this small video that I have here, and tell me, what do you think? Who the one that moves? Is it the woman inside the train, or maybe the train outside? So as you can see, we actually don't know. We cannot know until the end. Only now in the end we see, oh, actually it was the other train that moves, right? And this is because constant velocity is a relativistic phenomenon in physics, which means that our observer, this woman, she can do whatever physical experiment that she wants, and always she will see that she's at rest. For example, she can throw a ball on the air, and because of inertia, the ball will come back to her hand. So from her point of view, she's at rest. So now we can think about two observers, Alice and Bob. And Alice is on the platform of the train, and Bob is on the train, and it moves right in a constant velocity. So then Bob does experiments and see that he is at rest. So he will say, I'm at rest, you are the one that moves left. But then Alice tell him, no, I'm the one at rest, you are the one that moves to the right. So who is correct here? What is the right answer? And of course, this is the point of relativity. There is no right answer. It depends now. There is no absolute answer. It depends on the observer. So both of them, Alice and Bob, are just two frames of reference, and both of them right. They just describe reality from different point of views. But if they don't know that, velocity is relativistic, then they will continue to argue. Bob will say, well, I'm at rest. And then Alice will say, oh, you know what? You just have a delusion. What do you want from me? And then Bob, in order to do a counter argument, will say, you know what? I did all my experiments and I see that I'm at rest. So maybe it's just private property that you cannot see. Now, I hope it reminds you something, because this is exactly what we see nowadays with consciousness. Now, of course, both of them are wrong. Velocity is not delusion and not private, just relativistic. So let's see the same thing with consciousness now. Bob will say, I have phenomenal consciousness, but you just have neural patterns. And Alice will say, no, I have phenomenal consciousness, and you have just neural patterns. And then because they think there should be an absolute answer here, they will continue to argue until Alice will say it's just a delusion, and Bob will say it's a private property. So from this small, analog here, we can see how we need to speak about consciousness now as from different cognitive frames of reference, that both frames are correct, and it's just they describe the same underlying reality from different points of view. So to summarize this example, so we see that phenomenal consciousness, if it's relativistic, it means it's depend on the observer, and then it should not be private or delusional. So let's see more now. Let's go even deeper than that. And for that, we need another example of relativity from physics. And this is the Einstein equivalent principle. So think about a different two systems. This system, you see here, we have the spacecraft with the astronaut inside. And this spacecraft is on Earth. And then it's under gravitational field. So when she will release the ball will just fall because of the gravitational field. But then think about another system. Now our spacecraft is in space, and when she will release the ball, it should float near her, right? But if our spacecraft has acceleration upwards, then the floor of the spacecraft will go closer and closer to the floating ball, right? So because there is nothing above and beyond the observer, according to the relativistic principle, what she will observe is that the ball coming closer to the floor, exactly like if it was under gravitational field. So Einstein realized that there is an equivalence here between those two seemingly different systems. There is equivalent between gravitational field and acceleration. And then he did an ingenious thing. He inferred physical laws and phenomena from one system to the other because they are equivalent. So for example, he said, we know that there should be an effect that we call a redshift effect. We know that this is what happened under acceleration to the light. So because of this equivalent, now it should be that the same effect will happen also under gravitational field. And 60 years later, they actually measure it and saw that Einstein was correct. And we have this effect also in gravitational field. So let's do the same thing that Einstein did. What Einstein did here is he used the relativistic principle that says that if I have two observers in two seemingly different systems, but if they measure the same physical results, then it means that actually they are the same. There is equivalence between the two systems, and then they have the same laws of nature, and we can infer those laws and phenomena. So we'll do the same thing, but in order to do it in a more easy way, let's assume for a second that some broad physicalism just mean that there is some kind of physics, some kind of natural laws that explain consciousness. We don't know what it is. It might be something simple like illusionism. It might be something much more elaborate like naturalistic dualism, but there is some kind of physics here.